plus purple.
Plus 2 purple times 2.
Plus 2
We'll get
purple.
it.
Why 2 purple?
Well, because purple is only one half of the like thing. So you have to times by half to only get purple.
Oh, okay, go.
So if we had.
Hold up.
Yeah.
We only want.
Hold up. You're doing two different versions of the same thing, but you're mixing them together to chaos. So we get this, so we get 1 plus, no, we just get root 2, don't we? So green is root 2 minus 1 plus 1 equals 2. Okay. So we added purple and green. What shape have we got?
The same as blue.
Right. This plus this is the same as that shape, just flipped over.
Yeah.
So this must equal blue, which must equal red, which must equal pink.
Well, no, pink doesn't have that little white bit. Yeah, no, I meant that like it's going to draw the line and you see a little
That's purple.
That's purple. So this is all of this is pink.
Yeah. Yeah.
You're okay?
Yeah.
Okay.
That's fine.
Therefore, total area is 4 lots of root 2. Cool. Alright.
We just do all that like 0 to 5.
Sorry?
We just have cos minus sin x and integrate between 0 and 2 pi, and does that do the same thing?
Alright, let's do that as a test to see what happens.
You'll get sin equals 0 twice, and you'll get what equals
0 to 2 pi of, which way did you say? Sine minus cos, or cos minus sine?
I don't know if it works or not, I'm saying like the other one.
Alright, well let's test both of them and see what happens. Okay, integral of this thing would be what? Negative cos minus sine, 2 pi to 0. Okay, cos of 2 pi. One, right? It's negative though, so negative 1. Sine of 2 pi, 0, so minus 0. Cos of 0, 1, so I've got negative 1 again. Sine of 0, negative 1 plus, sorry, negative 1 minus negative 1, 0. Right? So that seems like, no, that doesn't work. Cos, go the other way around because, oh, well, cos was originally on top, so maybe that'll work, okay? Integrate this, sine of x plus cos.
I'm guessing the points where they intersect is the points where it sort of stops working as a whole big thing.
So we've got 0 plus 1 minus 0 plus 1 equals 0. Cool. So, can you take a massive shortcut like that? No. Why? Say it again, Adam. What'd you say? Why can't you take that shortcut?
Because it's based off when they flip, like, because it's what's on top and then
Perfect.
where they intersect.
Perfect. This is saying, take sine to be the bigger one. Right, okay, well this is no good because then that means this is a negative area. Then it's a positive area, negative area, negative area.
Yeah, and they all, I'm guessing, add up.
Yeah, they all cancel out. Oh, okay, well change it so it's the other way around. Well, that's no bloody good because all your positives and negatives switch still adds up to 0. So, what you have to be doing, do this in the general case.
In this instance, could we just go from pi on, was it pi 4 to 5 pi on 4 and then just double it?
Perfect. Or, even faster,
5 and 4 to 5 and just cancel it.
What would you like?
Okay, so there's a whole bunch of short ways you can do it. So that, yeah, going from pi on 4 to 5 pi on 4, and then times by 2, that's a perfectly valid way. Just make sure you've got sine on top, right? Alternatively, you can go, no, even shorter. The integral of, which do I want? This. You can go the integral from 0, because using zeros is always handy, to pi on 2, right?
Yeah.
Sorry, the integral of 0 to pi on 4 rather, right, of the difference, which gives you green,
Yeah.
right? Times that by 2 would give you that shape, and then just do a single integral under sine, right? And then, so you've got these two, give you those bits. This times 2 would give you the second bit, and then times the whole thing by 2 again, and you've got everything. All right, so you can partition these up, particularly with trig things. There's so many symmetries that you can just exploit. But it doesn't always happen. You might get something like that. And it says,
That doesn't look like a trig function. So.
okay, actually, I'm going to do this in different colours, just so that no, it's not supposed to be a trig function. Okay, so now if I ask, I want the area contained by these curves. Well, there's a bit going on.
Yeah.
And I'm going to end up needing to rub stuff out. I'm going to rub out this test because the test is useless, other than it tells us that it's wrong. I'm going to label this negative A just so that it's clear what's going on. Cool.
The A's and both negative and positive.
What?
Oh, no, the point's negative, yeah,
Yep.
in the area, like, in
Yeah, okay, cool. Beautiful. All right, I want to integrate this thing. 1, 2, 3, 4, 5, good. So I want. Blue, purple, red, green, get rid of it. Okay, some of these are going to be positive areas, some of them are going to be negative areas. Yeah? Okay. Just because I can, I'm going to define this to be a positive area, just because it's the first one. Is this positive or negative?
Negative.
Is this positive or negative?
Positive.
Is this positive or negative?
Positive.
Can I write a single statement that is the area of all of this
Can we label
with multiple integrals and everything? Say it again.
Can we label one?
Yep. We'll call this f of x. Call this g of x.
就你要这个这个是在上面，然后上面的去减下面的就是正的。如果这个
Okay, how do I get the first green area? Integral of f of x minus g of x
Between A and B, and negative A and B.
between negative a and b. Cool. All right. Then
把
1.
它减的那个。
Plus
Okay.
integral of G minus.
Okay. So you could flip it around.
对，在 f(x) 减 g(x) 的时候，从错那个位置。
start the exact same way. And then say, oh, I could minus this bit. So minus BC, and then I can have the same integral. Why might I want to do that? Right, once I've found one integral, I've got more. Then I'm just subbing in terminals. So that saves me a bit of time. C, D, minus G. Minus. E minus G plus E, F minus G. Okay, that's one thing. Is there, now I've still got a whole lot of minuses in here that could cause me trouble. Can I get rid of those? So leave the first one how it is. Then on the next one, I want this to be a plus. All right, reverse the terminals. Cool?
Yeah.
And then that way we can have pluses everywhere. This stays the same. This one switches. This stays the same. F minus G, F minus G, F minus G. Another good thing about this is that this way you've got the same number at the start of the interval for both. So once you figure out what it is when you sub B into it, you just use that in the next one. Once you figure this one out, just use that in the next one, and same story for the E's and the C's. You can do it all like that if you want, but then you're going to have to figure out two different intervals, and you're going to have, you're going to have to figure out two different intervals. That's fine, and your terminals are going to change position throughout. That's fine, you can do it that way. Or you can do it this way, where you're just doing one integral, but then you're going to have all of the negatives. Or you can make it one integral with all positives, and then you just have to keep track of which side your terminals are going on.
So does that mean you could integrate it once,
Yep.
calculate what each different point is of that integral, and
Yep.
then plug it into that?
Yes, that would be wise.
Yeah.
Right?
That sounds like it made it a lot easier than the original.
Right, it does. It makes it a lot easier, right? And these are why I teach you all these shortcuts and rules. Now, will this, even after all those shortcuts, will this be a quick and easy problem? No, it'll be a minor pain. But so long as you're systematic about it, it's actually surprisingly quick and easy. You just have to be a little bit careful. But
How do you get the intersects again? Is that where you're like subbing one equation to another equation? Like
yeah,
if
make
say-
one equation equal the other
Yeah, say
equation, yeah,
we
and then
do
solve
both.
for it. Yeah.
Yeah.
You just have to shift it all to one side, make it equal 0, then depending on what equation you get, you solve.
But if you had more than one intersect, does that change it?
So,
If you had more than one intersect, does that change it?
just when you solve it, you'll get negative A, B, C, D, E, and F. It'll give you all the intersections. That's it. That's 11 I. Beautiful. You'll be happy to know that the book will not give you things this tedious,
Yeah.
right? But it's handy to at least have seen them, just so you know what the deal is and so that you can write them out. Yeah, that's it. Beautiful. Questions, queries? Everyone's happy? Beautiful. Okay, bye.